So one more Bayes theorem session. Do a couple more examples. There's some quirky things that can happen with some of these. Here, let's do one that you'll run into in the homework, similar to one that you'll run into in the homework, right? So, machine A produces twice as many parts as machine B. Right? Machine A, for machine A, %8 of the parts are faulty. Let's just say bad. Oh, let's say faulty to avoid the B. I already have a B, right? And for machine B, let's say 5% of the parts are faulty. Okay. So this is kind of naturally a very natural Bayes theorem question. The thing that's quirky about this one is you weren't given percentages for machines A and B. You were given that machine A produces twice as many as machine B. Okay? So when we go to do our tree diagram, we're going to have to deal with how do we figure out how we deal with twice as many. And then 8% of A, 5% of B are faulty. Okay. So our first split, of course, is going to have to be machine A and machine B. And, oh, I should have done it. Oh well. And if machine A is going to produce twice as many as machine B, then you've got a total of those two machines are putting out a total of 3 objects, right? 2 from A and 1 from B every whatever unit of time. Let's say every second, 3 objects come out, 2 from A and 1 from B, right? So A is producing 2/3 and B is producing 1/3 of the objects. Now you can change these into decimals. You could use 2/3 could be 0.67 and 1/3 could be 0.33. Please do not use 0.66 for 2/3. That you need to round up because that next digit is a 5 or above, right? And then we've got the faulty parts and we have the not faulty. And so machine A was producing 8% faulty. Let's change 8% into a fraction. I think I'll work with fractions on this one. 8% is 8 out of 100. That's what percent means, right? And so that is 2 out of 25. Just to make it a nicer fraction, 2 out of 25. On the other hand, the non-faulty ones are going to be 23 out of 25, everything else, all right? And then machine B is producing 5%, so 5%, of course, is 5 out of 100, or 1 in 20. So we've got faulty, 1 in 20, and not faulty, 19 and 20. I don't really care if you work with the decimals or the fractions in this case. I think the fractions are going to be just a tad bit nicer. So what do we do first? Well, we multiply these out. That's 4 out of 75 faulty and from A. That's 46 out of 75 right? 46 and 4 add up to 50 out of 75, which is 2/3, of course. This is 1 in 60, faulty, and for B. And this is 19 and 60, adds up to 20 out of 60 are faulty for B. Okay. What is the probability that something is faulty, right? Well, it's faulty here or it's faulty here. So 4 in 75 plus 1 in 60. What's my common denominator there? I think 300 is my least common denominator. So this is 16 out of 300. Multiply top and bottom by 4. 75 times 2 is 150, and times 2 again is 300. And 4 on the top. And this is top and bottom by 5. 5 out of 300. And that is 21 out of 300. Oh, which interestingly enough is 7 out of 100, or 7%. I don't really care that it's 7%. We can use 7 out of 100. So that's the probability that something's faulty. What's the probability that it came from B, given that it's faulty? So our denominator, given that it's faulty, our denominator is the probability it's faulty, so 7 out of 100. And the numerator is, of those, which ones came from B? Well, that's these right here, 1 in 60. Remember, these are the A's and these are the B's. How do you divide fractions? You invert and multiply. This is 1 over 60 times 100 over 7. Right? We'll cancel a 0. This is 10 out of 42. I could have canceled again, I guess. Yeah. Or, if you prefer, 5 out of 21. Either one of those is perfectly acceptable. We did work with fractions in the it's about 4 videos ago, back when we did conditional probability, the tree diagram lecture on conditional probability. We worked with fractions, but you don't have to if you want to change everything into decimals. You do have to be ready for a little bit of inaccuracy in your answers if you're going to change to decimals. Frankly, if this is a quiz question and you need 3 digits of accuracy in your decimal, you should be probably carrying 4 digits as you're doing your calculations, or maybe even 5. So this one's going to be 0.66667, and this one's going to be 0.33333. And here you'd be using the 0.08 and the 0.92, and here you use the 0.05 and the 0.95, and work with those decimals, which is perfectly fine either way. Just try to make sure you're rounding carefully. Okay, so the 2/3 and the 1/3 you run into in a homework question, so I wanted to throw that out there. Maybe one more of these. I grab one out of the book. 43, I think it's setup's a little complicated in 43, but it's I thought it was an interesting question. An oil well is to be drilled in a certain location. The soil there is either rock, 0.53 probability, clay, 0.21 probability, or sand. Whatever is left is the probability. If it's rock, the geological tests give a positive result with 35% accuracy. If it's clay, gives a positive test result with 48% accuracy. And if it's sand, the test gives a positive result with 75% accuracy. The test is positive, right? Okay, so we got rock, 0.53. We have clay, 0.21. And we have sand. See, that's 74 So I believe that's 0.26. And the accuracy, if it's rock, it's 35% accurate. I don't particularly like the wording of this question, which is one reason I do it. If it's clay, it's 0.48 accuracy. And if it's sand, then it's 75% accurate. Okay? So, let's do that tree diagram. It could be either rock, clay, or sand, 0.53, 0.21, and 0.26, and it gives a positive result 35% of the time. This is why, the reason I don't like this wording is the word accuracy doesn't imply necessarily positive, but I'm quite sure this is what they're doing here, right? And that means it gives a negative result, 0.65. And with clay, you're going to get a positive result, 0.48, and a negative result, 0.52. What they really mean, I think, is if there is oil, this is the result you're going to get, which is a little different from just accuracy. So positive result 0.75 and a negative result 0.25 then. Okay, might need to crack the calculator for these. I think the book often only does the ones they want. I encourage you to do both. A lot of times I'll ask questions on both. Although the quizzes usually only ask one, but I think on the tests a lot of times I have one set up and then I'll ask you a few questions. So I'll encourage you to just do both as a habit. This is 0.1855, and because we're working with decimals and we want those 3 digits of accuracy, I will carry that out to 4 or even more if we need. Remember, 0.00021, how many digits of accuracy is that? That's only 2 significant digits, right? So that's not good enough to get 3 significant digits of accuracy in the end. Watch out for that. You will run into that in this section. And 0.53 times 0.65 is 0.3445. And then 21 times 48, 0.01008. That one, on the other hand, has 4 digits for accuracy, of course. And that means this is probably I'm getting a little tired, I better multiply this out. 0.1092. 75% of 26. That's 0.195. And 25% of 26 is 0.065. And those all look good to me. Okay, so let's answer some questions. What's the probability that there's a positive test result? So positive, we get this one, and this one. So that's going to be 0.1855 plus 0.1008 plus 0.195. Oh, I don't think so. 28, 63, 30, 68, 47, 68 maybe. I do them in my head sometimes because it's a good check for whether I got the calculator right. 0.4813. That sounds good. I think I forgot the 5 at the end. No. No, that's not what happened. Oh yeah, I put it in the wrong place. Okay, so 0.4813 is the probability of positive result. So what's the probability it was rock given that you got a positive result? So that's 0.4813. And of those, which ones were rock? That's these right here, 0.1855. Okay? Reciprocal times 1855. And that's 0.3854, so 0.385. Right? Or one more maybe, what's the probability that it was sand given that you got a positive result? And our sand is 0.195, and that's divided by 0.4813. So 0.195 divided by 0.48313. And that is 0.4051, so 0.405. A little higher than that one, of course. Setting it up, the tree diagram, multiplying that tree diagram out, and then working with these end results. Some people try to kind of work back in here in the tree diagram. You want to focus on those end results. That's why I have you multiply those out right away, so you can just focus on those questions. That's a lot of Bayes' theorem examples. I hope they help. I do recommend the tree diagrams rather than those formulas. But whatever works best for you. Good luck, everybody.